Welcome to Omni episode 49. Today we explore the fascinating, hidden underground world of termites and their incredible biological adaptations. Deep beneath the surface of the Earth lies a complex society where millions of tiny insects work tirelessly in complete, absolute darkness. Termites are often misunderstood as mere pests, but they actually represent a highly evolved system of biological engineering and strict social hierarchy. Within this massive subterranean fortress, every single individual has a specific role that dictates their physical form and their unique sensory capabilities. The termite colony operates like a single giant organism, where each caste functions as a specialized organ designed for a specific purpose. Let us focus our attention on the worker termites, who make up the vast majority of this incredibly busy and productive population. These tiny laborers spend their entire lives digging tunnels, gathering food, and caring for the young without ever seeing the sunlight. Because they live exclusively in the pitch-black underground environment, worker termites have completely lost their eyes through millions of evolutionary years. Being completely blind might seem like a terrible disadvantage, but in the dark tunnels, eyes are simply useless and highly vulnerable organs. Nature does not waste precious energy maintaining sensory organs that provide no practical benefit to the survival of the individual or colony. Instead of vision, these blind workers rely entirely on highly sensitive chemical receptors and tactile sensors located on their constantly moving antennae. They navigate their complex labyrinth using pheromone trails, which provide a much more reliable navigation system than vision in the absolute darkness. This is a perfect example of biological optimization, where resources are directed only toward the features that are absolutely essential for survival. Now let us shift our perspective to another crucial member of the termite society, known as the elate, or the winged termite. Unlike the blind workers, these reproductive individuals are destined for a completely different mission that requires a completely different set of tools. When the environmental conditions are perfectly right, the winged termites emerge from the dark colony and take flight into the bright sky. Their primary mission is to find a mate and establish a brand new colony far away from their original underground home base. Because they must navigate through the open air and avoid dangerous predators, these winged termites are equipped with fully developed compound eyes. Their vision is perfectly adapted to detect movement changes and light intensity in the presence of potential mates during their mating flight. The stark contrast between the blind workers and the sighted winged termites reveals a profound lesson about resource allocation and functional design. Within the exact same species, we see two completely different sensory configurations, dictated entirely by the specific requirements of their assigned jobs. The termite colony teaches us that absolute perfection is not about having every possible feature, but having exactly what the task demands. This fascinating biological principle is known as purpose-driven design, and it has profound implications for how we build our modern technology. In the world of modern engineering and surveillance systems, we often fall into the trap of wanting every single high-end feature. We assume that a better camera must always have the highest resolution, the most advanced sensors, and the most complex processing algorithms. However, the blind worker termite reminds us that adding unnecessary features only increases the overall cost and the complexity of the system. Imagine deploying a highly expensive 8K resolution camera in a completely dark warehouse, where only simple motion tracking is actually needed. Just like eyes on a worker termite, those expensive optical sensors would be completely wasted in an environment that lacks sufficient illumination. A much more efficient approach would be to deploy simple infrared sensors or thermal imaging cameras that are specifically designed for darkness. By embracing the philosophy of purpose-driven design, we can create surveillance networks that are much more robust, efficient, and cost-effective. Every single component in a technological system should be carefully evaluated based on its actual utility within the specific intended operating environment. We must ask ourselves, what is the primary mission of this device? And what are the minimum sensory requirements to achieve success? If the device only needs to detect temperature changes, then adding a high-definition optical lens is nothing but a foolish waste. The winged termite needs eyes because its survival depends on aerial navigation, while the worker needs chemical sensors for its dark tunnels. Similarly, a drone flying high above the city requires advanced optical cameras to navigate and identify complex targets in the bright daylight. Meanwhile, a simple security sensor placed inside a closed vault only needs to detect a basic interruption in a simple laser beam. When we design systems with this level of specific focus, we reduce the power consumption and we dramatically increase the overall reliability. Complex systems with unnecessary features are much more prone to unexpected failures, and they require significantly more maintenance over their operational lifespan. Nature figured out this optimization strategy millions of years ago by ruthlessly eliminating any biological feature that did not contribute to survival. The evolution of the termite caste system is a masterclass in modular design, where different units are optimized for highly specific functions. As we continue to develop artificial intelligence and smart cities, we must keep the humble termite in mind to guide our innovations. We should strive to build networks of highly specialized sensors rather than deploying generic devices that try to do absolutely everything everywhere. A smart city does not need ultra-high-definition cameras on every single street corner to monitor the basic flow of traffic. Simple radar or LiDAR sensors can track vehicle movements much more efficiently, without violating the personal privacy of the citizens walking below. This selective approach to sensory technology allows us to gather the necessary data while minimizing the massive computational burden on our servers. Just as the termite colony conserves its collective energy by keeping workers blind, we can conserve massive amounts of electrical computing power. Processing high-resolution video feeds from thousands of unnecessary cameras requires massive data centers that consume enormous amounts of valuable electrical energy. By deploying the right sensor for the right job, we can drastically reduce the carbon footprint of our modern global surveillance infrastructure. The blind worker termite is actually a champion of efficiency, perfectly adapted to its dark world, without any useless visual processing overhead. Its brain is entirely dedicated to processing chemical signals and mechanical vibrations, which are the only inputs that truly matter underground today. In our artificial intelligence systems, we should also aim to reduce the noise by limiting the input data to what is relevant. Feeding an algorithm with too much irrelevant information can actually decrease its accuracy and slow down its critical decision-making processing speed. A purpose-driven sensor provides clean and highly specific data that allows the central intelligence to make rapid and highly accurate decisions. The winged termite, on the other hand, uses its complex eyes only during that brief but critical period of the mating flight. Once the flight is over and a new colony is established, the royal couple will shed their wings and retreat underground forever. They will never need to use their eyes again, proving that even within a single lifetime, sensory needs can drastically change completely. This dynamic adaptation inspires us to design technological systems that can activate or deactivate their sensors based on the current environmental context. A smart security camera might keep its optical sensor turned off during the night and rely entirely on low-power motion detectors. Only when motion is detected will the system activate its more energy-intensive sensors to capture a detailed image of the intruder. This hybrid approach perfectly mirrors the biological flexibility we observe in nature and represents the future of sustainable and efficient smart technology. The study of biomimicry often leads us to these profound realizations, where ancient biological solutions solve our most complex modern engineering problems. We realize that nature is the ultimate engineer, having tested and refined its designs through billions of years of relentless evolutionary pressure. The termite mound itself is a marvel of passive ventilation and temperature control, maintaining a perfect internal climate without any electrical power. But it is their sensory adaptation that truly highlights the elegant philosophy of giving an organism exactly what it needs to succeed. When we look at a blind termite, we should not see a disabled creature, but rather a perfectly optimized machine of nature. It is a living testament to the fact that sometimes less is truly more when it comes to long-term operational efficiency. As engineers and designers, we must learn to resist the constant temptation of feature creep and focus on the core fundamental requirements. We must have the courage to remove components that look impressive on a specification sheet, but offer no real value in practice. A truly elegant design is not one where nothing more can be added, but one where absolutely nothing more can be removed. The termite colony thrives because it embraces this minimalist philosophy at the biological level, ensuring maximum productivity with absolutely minimal energy waste. Imagine a world where all our technological infrastructure operates with the same level of harmonious efficiency as a natural, healthy termite colony. Our cities would consume a fraction of the power they do today, and our data networks would be free from unnecessary congestion. Devices would be cheaper to manufacture, easier to maintain, and significantly less damaging to the delicate natural environment we all share together. This vision of the future is entirely possible if we are willing to learn from the humble creatures that live right beneath us. We must shift our mindset from trying to dominate nature to carefully observing and respectfully copying its highly successful and proven strategies. The next time you see a surveillance camera or a complex sensor network, take a moment to consider its true, fundamental purpose. Ask yourself if it is designed like a winged termite ready for flight, or like a blind worker perfectly suited for darkness. Recognizing this distinction is the very first step toward building a more intelligent and resource-efficient technological ecosystem for our future generations. In the grand tapestry of life, every creature holds a unique lesson waiting to be discovered by those who simply pay attention. The termites have spent millions of years perfecting their society, and their sensory adaptations are a crucial part of their enduring success. They have survived mass extinctions and dramatic climate shifts by remaining highly adaptable and ruthlessly efficient in their biological and social organization. We human beings are a relatively young species, and our modern technology is still in its absolute infancy compared to natural evolution. By studying these ancient survivors, we can accelerate our own technological development and avoid making costly mistakes in our complex engineering projects. Purpose-driven design is not just a clever engineering concept. It is a fundamental law of survival in a highly competitive universe. Resources will always be limited, whether it is biological energy in a dark tunnel or electrical power in a massive data center. Those who can achieve their goals using the absolute minimum amount of resources will always have a massive advantage over their competitors. The blind termite worker is a tiny but powerful reminder of this universal truth, silently digging its tunnels in the eternal dark. It does not need to see the beautiful world above, because its entire universe is defined by the chemical trails it follows. And yet, without these blind workers, the entire colony would quickly starve and collapse, proving that their specialized role is absolutely vital. The winged termites may get to see the sun and experience the freedom of flight, but their success depends entirely on workers. This interdependence highlights another important lesson about how different specialized units must work together to achieve a much larger and complex goal. A network of simple blind sensors can support a few highly advanced optical cameras, creating a comprehensive and highly efficient surveillance system. We do not need every node in the network to be a genius. We just need them to do their specific jobs. The beauty of the termite system lies in its incredible simplicity at the individual level and its profound complexity at group level. This is the ultimate goal of artificial intelligence swarm robotics, where simple individual agents collaborate to perform highly complex and difficult tasks. By stripping away unnecessary sensors from these individual robots, we can make them much smaller, cheaper, and far more robust in operation. They can explore dangerous environments like collapsed buildings or deep ocean trenches without risking highly expensive and delicate optical camera equipment setups. The lessons from episode 49 of Omni show us that true innovation often means looking backward into the natural world. We must embrace the wisdom of the blind worker termite and apply its philosophy of purpose-driven design to our modern lives. Let us build technology that is smart, efficient, and perfectly adapted to its environment, just like the fascinating creatures we studied today. As we conclude our deep dive into the subterranean world of termites, we hope you have gained a new perspective on design. Remember that true perfection is achieved not when there is nothing left to add, but when there is nothing left to remove. Thank you for joining us on this incredible journey through biology and technology, where nature provides the ultimate blueprint for human innovation. We will continue to explore the fascinating intersections between natural evolution and modern engineering in our upcoming episodes of this documentary series. This is Omni signing off for today, reminding you to always look closely at the world because design is absolutely everywhere.